Okay, so today we're going to work with arithmetic series. We've been working with sequences. Sequences are numbers separated, pattern of numbers separated by commas. Sequences have, technically, generally speaking, have no end. They go on forever. Series, generally speaking, do have an end point. A series is a sum of a certain number of sequences in a sequence separated by a plus or minus. In other words, instead of having 1, comma 2, comma 3, comma 4, comma 5, we'll have 4 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. We will have a sum. We're adding or subtracting all the numbers. So you can be separated by a plus or a minus. It's still arithmetic in the way that you come up with it. But instead of having just a list of numbers, they are numbers added together. So generally speaking, you will have an end to your sequence, and you'll be able to come up with a total for it. Now, there are some series that do go on forever that you can still find a total for, but we don't deal with that in here. Okay. We've done the arithmetic sequence formula. We will be using it again today. Significantly, we'll be looking for particular terms and term numbers so we can use the other two formulas. The arithmetic summation notation, this is an important one. Okay, summation notation, this is called an epsilon. No. This is sigma notation. There you go, sigma notation. Okay, from n equals 1 to n. So this is a way of adding them up, writing them as a formula, rather than writing out each and every term. This is just a way of stating the sequences using a formula. Sorry, it's a series using a formula, rather than writing out 1 plus 2 plus 3 plus 4 plus 5. A way of doing that. That's what it means. How many terms we have? We start with the number here, and go to whatever that is. If it's from 1 to 40, that means there's 40 terms. If it's from 1 to 10, that means there's 10 terms. Okay, it's fairly simple along those lines. This is just a way of writing a series in another manner. We will do that. And then the other new formula that you will be using that will be a very important one as well is the arithmetic series formula. This is to find the total. If I want to add up all the numbers, this is the formula you use to do so. It's the number of terms in your formula, it's in your series, divided by 2, times the first one plus the last one. Okay, that's what that formula is. S sub n is the sum being total. You're going to add them all together. Okay. S sub n is the sum of n terms. So if I have 20 terms, the sum of the first 20 added together. N is the number of terms. A sub 1 is the value of the first term. A sub n is the value of the nth term, in this case, the last one. Okay, so the last little blurb on here. Okay, one of my many interests is mathematical history. I have an interest in mathematicians and the history of mathematics, where it came from. It's just I had a class in college. I found it really interesting. I kind of follow it. And this is one of the more interesting stories. It says find the sum of the first 100 whole numbers, as Carl Gauss did when he was 9 years old. Carl Gauss is one of the greatest mathematicians that ever lived. He actually, before Germany went on the euro, his money was on the 5 mark note. His picture was on money. Okay, mathematician, face on money, that's a big deal. Okay, he did a lot of stuff in a lot of different areas. There's a lot of things that we have used. When you solve the system equations by elimination, he's the one that came up with that. Okay, it's called Gaussian elimination. We don't call it that here, but that is what it's from. He's done a lot of other things, and he was a prodigy. The story goes that when he was school, and you got to realize he lived a few hundred years ago, a couple hundred years ago. When he was in school one day, his teacher was, okay, here's your assignment for the day. I want you to add up the first 100 numbers, 1 plus 2 plus 3 plus 4, and so on. And the kids, and she says, when you're done, put the total on your slate, turn it on my desk. And the idea is the kids are going to take a while to add up the numbers. She's going to get some time to do some work or whatever. And, they're going to take a while. Well, it took him about 2 minutes. And he was done, basically like that. And here is how he did it. So what you're doing is you're taking 1 plus 2 plus 3 plus 98 plus 99 plus 100, the first 100 numbers. Okay. And here's what he saw. He goes, okay, if I take the first number and add it to the last number, I get 101. If I take the second number and add it to the second to the last number and add them together, I get 101. If I take the third number plus the third from the end, I get 101. And if I take the fourth number plus the fourth from the end and keep doing that, working my way in, every single pair adds up to 101. How many pairs are there? Well, when I get down to the middle, my middle two numbers would be 50 plus 51. So I would have 50 pairs of numbers that add up to 101. So if I take 101 times 50, that's my answer. 5,050. And he wrote it down and gave it to us. When he was 9 years old.
Fake news.
Don't think so. Makes you feel kind of small and insignificant, stupid. But you got to realize there are people who have this kind of ability. They have the ability to see things. And they have the ability to pick out patterns and stuff. And everybody, there are prodigies in every field. He just happened to be a child prodigy in the field of mathematics. He saw things. He got them quickly, got them easily. But it does show, it's nice. This is about patterns and recognizing patterns. Now, our first example is essentially that same thing. But let's use the formula that we have here, the sum of the first n numbers. And if you look at it, it will work out to be the same process. He just figured out doing it without knowing the formula per se. And the teacher expected, okay, 1 plus 2 is 3, 3 plus 3 is 6, 3 plus 4 is 10, and the kids to do it all like that. That's what she expected them to do. And that would take a long time. I mean, that would really take quite a while to do it all by hand, to add up the numbers one at a time. Take a long time. That's what she expected. However, if we use the formula, it works out well. We need three things for the formula. We need the first number, we need the last number, and we need to know how many numbers there are in the sequence. How many numbers are there? Well, this one's easy. It's 1 to 100. There are 100 numbers. Okay. Bless you. So the sum of the first 100 numbers is equal to 100 divided by 2 times the first number plus the last number. This is exactly what he did. Because the first number plus the last number is 101. The total divided by 2 is 50. 50 times 101, 5,050. So that's our formula. How many terms we have divided by 2 times the first one plus the last one. So we need to know the first term, we need to know the last term, we need to know how many there are. That one's pretty easy to figure all those things out. This one, well, it's going to require a little more work. I know the first one, I know the last one, What I don't know is how many there are. So I have to figure that out. Well, we did that back when we worked on arithmetic sequences. We used this formula. Plug in the last term, plug in the first term, plug in the difference, solve for how many. So this is 99 equals, equals the first term 4 plus n minus 1 times d. What's our d? How do I get from one number to the next?
Add 4. Or 5.
Add 5. Solve for d. So 99 equals 4 plus, I'm sorry, I didn't write down what d was. I just wrote d, my bad. That's 5. So 5 n minus 5. So 4 minus 5 gives me negative 1. Add that to the other side. 100 equals 5n. So n equals 20. So I've got 20 numbers added together. And when we did this, last week, but we did do this. Okay. Plug it into the top formula, solve for how many there are to figure out how many terms are in the sequence. Now I have the three things I need to figure out the total. So I have to have the number, the first, and the last. So my total of the first 20 numbers, because it is the 20th term, was the last one there, equals 20 divided by 2 times 4 plus 99. First term, last term, how many there are divided by 2. So 20 divided by 2 is 10. 4 plus 99 is 103, right? 103 times 10. You shouldn't need a calculator to figure out that's 1,030. Okay, does that make sense? Okay, next one, a little more complicated. I have my first term. I have how many terms there are, n equals 190. What don't I have? I don't have the last one. But we have something that will help us find the last one. The 190th term is equal to negative 9.3 plus 190 minus 1 times d. And we're going to put my calculator, here it is. And to find d, we take one of the numbers, subtract the one before it. So negative 6.3 minus negative 7.8, and you get 1.5. So negative 9.3 plus 189 times 1.5, execute. So the 190th term ends up being 181.2. Now I have the three things I need. First term, last term, and how many there are. Plug into the formula. First term, last term, how many there are. Sum of the first 190 is 190 divided by 2 times negative 9.3 plus 181.2.
Wait, wouldn't it be 181.2, not 190?
No, 181.2 is the term number, not how many there are. It's the 190. I got 190 terms in my sequence. The first one is negative 9.3. The last one was 181. And when you add them all together, you get 16,330 and a half. Would you like to add all those together by hand? Yeah. Formulas, it's actually a simple formula to use. It's a nice formula. It's easy. It's clean. You do have to know three things. First, last, and how many. Okay. This one, I know my first term. I know how many. I need to find my last. To find my last, I'm going to want to figure out D first. Okay. Now, I could make them all common denominators to do that, but my calculator will handle the mixed numbers. Screw it. I'm doing the mixed number bit. It's just so much easier here. So, 3 and 3/5 minus 6 and 1/10 gives me -5/2. I'm going to go ahead and leave D as -5/2 because that's what my calculator spit out. Makes it easy to do. To find D, remember you pick a number. Ooh, I screwed up. No, that's a plus. Never mind. You take the last. You take a number, 3 and 3/5, and subtract the one before it, 6 and 1/10. And in this case, I get -5/2 or -2.5. Now, mine spit it out as an improper fraction. If you're spitting it out as a mixed number, -2.5, that's okay. It doesn't matter. It'll still work anyways. Yes. You hit the fraction button twice between the three parts. So I type in, when I did the 3 and 3/5, I hit 3 fraction button, 3 fraction button 5, and it comes up 3 and 3/5. Okay, did you understand that? So I hit 3 fraction button 3 fraction button 5, and that will come up as 3, 3, 5, and that's 3 and 3/5. That's a mixed number. That's how your calculator does a mixed number. Okay. And then you have a button. There's actually a button that goes back and forth between improper and mixed numbers, and you can take them both either direction. But I wouldn't worry about it. So I'm looking for my last term. A sub 16 is the first term, 6 and 1/10 plus 16 minus 1 times -5/2. So let's see, times 15, execute, plus 6, 1/10. And I end up getting 157/5, -157/5.
Wait, can we get 31 and 2/5?
Which would be 31 and, would it be 31? Yeah, 31 and 2/5 is what it would be. Which would be the equivalent of -31 and 2/5. That would be the equivalent. Either one will work for what we're doing here. Either way would be fine. I'm not going to give you numbers quite that complicated on the test, but the process is still the same. So I need to find my total. The sum of the first 16 numbers is 16 divided by 2 times my first number, 6 and 1/10, plus my last number, which was -31 and 2/5. Plus 6 and 1/10, times 8. And I get -112, -1,000, -1,000 and 12/5. Two. 202 is negative 202 and 2/5. Like I said, yeah, fractions are kind of a pain in the butt. Get over it. Other than working the fractions on your calculator, do you have questions? Because really, it's use this formula, the sum of the first n terms. You need to know how many terms first and last. Once you have those three things, just plug them in. You might have to find one or two of those three things. Okay. There you go. And to find one or two of those three things, you're more than likely going to need this first formula that we used previously. Okay, okay, so let's do this. So the first one, you set it up to solve for n. 55 equals 5 plus n minus 1 times 10. The difference is 10. You solve it, you get n is 16. So the sum of the first 16 terms, 16 divided by 2 times 5 plus 155, so 160 times 8, and you get 1280. Okay. The next one, I did not use the formula to find n. I reasoned it out. I'm going 2, 4, 6, 8, 10, 12. Every other number up to 100, doing the even ones. How many even numbers are in the first 100? There are 50 of them. Okay, because if there's 100 numbers in there, half of those, there would be 50. So it's 50 numbers to get up to there, so n is 50. If you did set up the formula to solve for n, you should also get 50 either way. So the sum of the first 50 even numbers is 50 divided by 2 times 2 plus 100, and you get 2550. What did you get for that one? Yes?
How did you get that answer for the first question?
What do you mean, the n?
Yeah, 155 plus 5 is 200, and then times 8 is like 60.
Okay. So you get minus 5. This will be 160. 10n. So when you do this out, you end up getting 155 equals 5 plus 10n minus 10, right? 5 minus 10 is negative 5. Add 5 to both sides. You get 160 equals 10n. Divide by 10. N equals 16. Okay.
But I'm just talking about how we got like the 5 on it.
This?
Yeah.
5 plus 155 is 160 times 8. It's half of 16. Yeah, okay. Don't forget to divide by 2. That's the most commonly missed portion. It's not dividing by 2. Okay. And once again, these formulas will be on the board when you take your test. I am going to take them down when I do the testing. The standardized testing. CAAS PP. CAAS. I'm not allowed to have math crap up on the wall. So I got to take that down during the test. But I'll put it back up. Okay. So on the next one, I have how many terms? 342. I have the first one. I need the last one. So my A sub 342 is 10 plus 342 minus 1 times D. D in this case is negative 3. So 10 plus 341 times negative 3. And I get negative 1013. That's my last number. So my total of the first 342 is 342 divided by 2 times 10 plus negative 1013. So plus 10 times 342 divided by 2. And I get, woo, negative 171,513. That's a lot. Okay. So next one, I need to figure out what my 75th term is. My first term is 11.6 plus 75 minus 1 times D, which is 0.25. So my last number in my sequence, the 75th one, is 30.1. So my total for 75 terms is 75 divided by 2 times the first number, 11.6, plus the last number, 30.1. And I get 1,563.75. Question?
Summation notation.
All right. Put it into summation notation. So, to put it into summation notation, I need 3 things. I need to know the first term. I need to know how many terms are there, and I need to be able to put that in 2 places. And I need to know what D is. Okay? So my first term, A sub 1 is 2. My D that I need to know is 2. And then I need to know how many terms there are. Well, how many do I have in that sequence? No, I don't have 30 numbers in there. How many numbers do I have in there? I've got 15, so I'm counting up the even numbers. 2, 4, 6, 8, right? So it'd be half of the last number. So my N would be 15.
Wait a second, am I stupid or is that not fucking happening? How's that going?
30 is not the 30 is the last number. 30 is not how many are in the sequence. Because I want to know N is how many are in there. How many are in the sequence? How many total are in there? How many terms do I have in there? So I'm going 2, 4, 6, 8. I'm not counting, right? Okay. Okay. So those are my 3 things I need to use my summation formula. And N appears in here twice. So my formula is the sum of the first terms from N equals 1 to 15. So it's the first 15 terms. That's a sigma. It's actually more an E, but it's sigma notation because it's Greek. And you'll see it when it's typed up. It looks better. Okay. And then plug in the formula. First term plus N minus 1 times D. Okay. Guys. Now. This is not completely finished, but I've got everything in there. All I need to do is simplify the formula. Distribute the two, combine up like terms. Okay? So I need to distribute 2 across here. I get 2n minus 2, right? Combine up like terms. So this one actually ends up being from n equals 1 to 15 of 2n. So I distribute the 2 and combine up like terms by 2 in the beginning and the minus 2 at the end. Cancel, I get 2n. And that kind of makes sense. What is my first term? It's 2 times 1. What's my second term? 2 times 2. What's my third term? 2 times 3. All the way up to my last term, which is 2 times 15. So that kind of makes sense. This formula makes sense with what I have.
Wait, why would you put up the giant?
Because that's what summation notation is. It's just a different way. This, and this are 2 ways of saying the same thing. That's what that is. 2 ways of saying the same thing. Okay, that's exactly what they are. 2 different ways of saying the exact same thing. That's what that is. Okay. So if I do the next one, what do I need? I need to know the first term. I need to know D, which in this case is 15. And I need to know how many terms there are. What is my N? That's not as easy to figure out on this one as it was on the first one. First one was easy. Ooh, I'm counting the even numbers, take whatever the last number is, divided by 2. This one doesn't work that way. This one I have to use the formula to solve for N. 305 equals 125 plus n minus 1 times 15. 305 equals 125 plus 15 n minus 15. When you combine up like terms over here, negative 15 and positive 125 ends up being 110. Subtract 110 from both sides. So I end up getting with 195 equals 15n divided by 15. And I get n equals 13. Those are the 3 things I need to have. I need to have how many, I need to have my D, and I need to know the first one. Summation notation. N goes from 1 to 15 in this case. So I have the sum goes from n equals 1 to 15, the first 15, sorry, 13, 13, 13, 13. N is 13, D is 15, 13. And then plug in my formula, 125 plus n minus 1 times D, which is 15. Yes, question?
Is and or
For the purposes of what we're doing here, yes, but it isn't always. But for what we're doing, when we're writing the summation notation, it does start with 1, but it doesn't, and you'll actually see that coming up in a couple of minutes. It could go from any number to any other number. It can even technically go backwards. It generally doesn't, but it can. It can go from a larger number to a smaller number. You rarely see that. Okay, you really don't see that very often. Usually it's from 1 to whatever. But in theory, I don't have to start the beginning to the end. I can pick any section in the middle. Let's say I don't want to add up the first 30 numbers. I want to add up the middle 10. I go from 11 to 20 and just add up the ones in the middle. And you can do that. Okay? You don't like to. It's not very fun, but you can do it. Okay. Yes?
you were done 15.
Because D is 15. Well, n is 13, d is 15. Okay, and then simplify, combine up like terms. So my final answer would be the sum from n equals 1 to 13. This would be 15n plus 110. Those are what you get when you distribute and combine up like terms. Okay? So remember, you need to write the formula, you need three things. You need to know what the first term is, you need to know what d is, and you need to know n for two different places. If you're not given those three things, you need to find them. You will be given two. In this case, you were given two. You were actually given one, and you had to find the other ones. But D is pretty easy to find, and N isn't that hard either. We did that before. That's not new. Okay. So I'm not going to worry about these two. They will be in the notes that I post online. I want you to do these two. Okay. So in this one here, once again, our first number is 26. Our D is 7, because we're going up by 7 each time. We do have to figure out N. 51 equals negative 26 plus N minus 1 times 7. So 51 equals negative 26 plus 7N minus 7. So let's see, 51 plus 26 plus 7, enter, divide by 7, enter, and you get N equals 12. So I have my first term, I have my D, I have my N. So I have the sum from N equals 1 to 12 of negative 26 plus N minus 1 times 7. Distribute, combine up. I get the sum from N equals 1 to 12 of 7N minus 33. Okay? Because it just distribute, combine up like terms.
12.
Yeah, 12 is the number of terms. Okay, so this one, my first term is 42.6. My D is 0.2. Sorry. No, it's not 0.2. My D is, I'm going down, my bad. 40.8 minus 42.6. Negative 1.8. D equals negative 1.8. I need to solve for N. So I take my last term, 15.6, is equal to my first term, 42.6, plus N minus 1 times negative 1.8. 15.6 equals 42.6 minus 1.8 N plus 1.8. So I subtract 1.8 and 42.6 from each side. 15.6 minus 42.6 minus 1.8 equals negative 28.8 equals negative 1.8 N. N equals 16. So these are the things I need. How many terms, what the difference is, and what the first one is. So I have the sum from N equals 1 to 16 of 42.6 plus N minus 1 times d, which is negative 1.8. And simplify that out. So I get the sum from n equals 1 to 16 of negative 1.8n plus 44.4. So find the parts, plug them in. Problem is, you've got a lot of formulas to work with. You have to remember which one's which one do we use what for. Okay, here's the easy part. Find the number of terms in the series. So this answers your question. Is always 1 to whatever? No, not always 1 to whatever. I can start at any number I want. I can end at any number I want. To find out how many terms are in the sequence, it's actually pretty easy. So in the first one, how many are in here? 8, because I start at 1 and end at 8. This one's easy. This is 8. When the numbers in the in the lower part are not 1, that's where it gets a little more difficult, but really it's easy. Okay? So in the second one, I go from 0 to 20. If I went from 1 to 20, I'd have 20, right? But I'm starting before that. I'm starting at 0. So instead of 20, I'd have 21. Now, there is a formula for this. Take the upper number minus the lower number, and then add 1. I get 21. That works for this. Upper number minus the lower number plus 1. I get that. That's all you have to do. Take the upper one minus the lower one. 9 minus 3, and then add 1 to that. 9 minus 3 is 6 plus 1. There are 7 numbers in that sequence. 56 minus 2 plus 1. That would be 55. And then the last one, 98 minus 12 plus 1. 98 minus 12 is 86 plus 1 is 87. That's it. The easy part of the test. The easy part of the homework. How many are there? Okay. Do these. We'll race. You with your calculators, me without. And if you've already done them, that doesn't count. Go. Yes. Yeah. You're not finding the total. Right. You need to know what the total is in order to be able to figure it out. That may or may not work. You can do that. It may or may not work. Okay. And if you can do that, you can probably rearrange this. Yes. First at last, subtract, solve for D. You can do it. Do what you did is basically in your head rearrange the formula. That's what you did. Okay. Oops. There we go. No, 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 no. No. I hate when things aren't working well. There we go. Okay. So, we're not going to do all of these. Well, yeah, we can do them all. We got time. Okay, write out the first 5 terms and determining if it's arithmetic, geometric, find D or R. So you did this. You did this on the first day. You just didn't have the sigma notation to go with it. You did this. You have a formula, write out the first 5 terms. You just didn't have sigma notation as part of it. So when I do this, I want to go, what do? I start with 1. I plug in 1 for n. So my first term, 2 times 1 plus 3, that's 5. So that's my first term, a sub 1. A sub 2, plug in 2 for n. 2 times 2 is 4 plus 3, that's 7. Plug in 3. My third term, 3 times 2 is 6 plus 3 is 9. Do my fourth term, a sub 4. 4 times 2 is 8 plus 3 is 11. Do my fifth term. 5 times 2 is 10 plus 3 is 13. We did this. You just have the sigma notation in front of the formula. Yes?
So all you're doing is basically...
First 5, yeah.
So if I take 2 times 2 to get the second term?
Yep. You're just letting n be 1, and then let n be 2, then let n be 3, then let n be 4, then let n be 5. That's it. And then tell me, is this arithmetic or geometric? What am I increasing by each time?
2.
I'm adding to each time, so that's arithmetic.
Oh, geometric.
And D equals 2. Yeah, we did this. We actually did do this. It just didn't have the notation in front. That's the only difference. We plugged them into the formulas. We did this on the first day of this chapter. Generate the first 5 terms of the sequence. Yeah. So, says first 5, not the first 10. We're not going all the way to 10. Don't panic. Just because it says from 1 to 10 doesn't mean we're doing from 1 to 10. We're only doing the first 5, not all of them. So I plug in 1. So my first term, actually, let's change colors to give a break between the two. A sub 1, first term, let n be 1. Plug in 1 for n. That's 4. 6 minus 4 is 2. A sub 2. Plug in 2. 2 times 4 is 8. 6 minus 8 is negative 2. A sub 3. Plug in 3. 3 times 4 is 12. 6 minus 12, negative 6. Plug in 4. 4 times 4 is 16. 6 minus 16 is negative 10. And then plug in 5. 5 times 4 is 20. 6 minus 20 is negative 14. First 5 terms, plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. Is this arithmetic or geometric? Is it going up by adding or subtracting? Yeah, what am I doing? I'm actually subtracting 4 each time, right? So this is arithmetic. And D equals negative 4. So I look at the next one. No, we are not doing the first 18 terms. There are 18 terms in that series. We're not doing the first 18. We're only doing the first 5. So plug in 1 for 5, 1 for n. So a sub 1. Plug in 1. So I have 3 to the first, which is 3 times 2, which is 6. A sub 2. Which means I have 3 squared, which is 18. Sorry, 3 squared, which is 9. 9 times 2 gives me 18. A sub 3. 3 cubed is 27. 27 times 2 is 54. Fourth term, a sub 4. 3 to the 4th power is 81. 81 times 2 is 162. And then the 5th term, a sub 5. 3 to the 5th, which is 243. 2 times 243 is 486. Is this arithmetic? No, I'm not adding the same amount each time. Is this geometric? Yes. What am I increasing by each time? By 3. This is geometric. And R equals 3. And we've worked with geometric formulas. You should say, ooh, R to some power. R to the nth or R to the n minus 1, either one. That means I have a geometric pattern. Okay. So if I look at this one here, and we're not going to do all of these because I do want to get to a couple other things. We're not going to get to our quiz today. We'll postpone that for another day. So if I look at this one, I want the first 5 terms. This one's actually pretty easy. 5 to the first power. A sub 2, 5 squared. A sub 3, 5 cubed. A sub 4, 5 to the 4th. A sub 5 is 5 to the 5th power. $31.25. Somebody check, make sure that I got that right. $31.25 for the 5th. Okay. And this one would be a what? Geometric arithmetic. It'd be geometric. And R is 5. Because I have 5 to some power. Now, without generating the numbers, if I look at this one here, 1/2 times 2 to the nth power. Is this one going to be geometric or arithmetic? It's going to be geometric, and my R would be 2. If I have something raised to 2 power, and there's no addition involved, then it's geometric. So this one would be geo, and R would be 2, the number raised to the power. If I look at this one here, this is a linear type equation. This one would be arithmetic, and D would be 3, the number times n. If I have some number raised to the nth power, that's geometric. If I have some number times n, that's arithmetic. And pretty much I can go with that. Okay, these are yours. I'm going to do them. They'll be on the notes. Okay. Find the sum. So we're doing this one here. Find the sum. We need to know how many there are. We need to know the first one, and we need to know the last one. Okay, how many are there? I'm going from 1 to 40. How many do I have?
40.
40. So n equals 40. I'm adding up the first 40 terms. The first term, plug in 40. Plug in 1. A sub 1. 3 times 1 minus 8 gives me -5. Plug in 40 to get the last term.
Oh, that's 40.
3 times 40 minus 8. 3 times 40 is 120 minus 8 is 112. Yeah. Those are the things I need. The first term, last term, and how many terms I'm adding up. Because that's what the formula asks for. So I have the sum of the first 40 terms is 40 divided by 2 times -5 plus 112. First term, last term, how many I'm adding together divided by 2? And I get 2140. Now, I was asked earlier, do we always go to 1 to whatever? No, we don't. I'm not adding up the first 14 terms. I'm adding up term number 6 through term number 14. Could be more in front. Well, definitely there's 5 more in front of the first one I'm starting with, and there's definitely a bunch at the end. But I'm only adding up that chunk in the middle from 6 to 14. So how many am I adding together? We did this a minute ago. The number of terms we're adding together is the top minus the bottom plus 1. Okay, 14 minus 6 is 8 plus 1 is 9. We're adding together 9 terms. We're going from the 6th term to the 14th term. Okay. So I don't want a sub 1, I want a sub 6 because I'm starting with 6. Which is 3 minus 1/2 times 6, which is 0. So the first number in my sequence I'm adding up is 0. Okay? That'll actually make my total nice. My 14th term, and we're going from 6 to 14. So my 14th term, 3 minus 1/2 times 14.
Oh, 14th to last.
14th term, right? Because I'm going from what? N equals 6 to N equals 14. 14, that's 7. 3 minus 7, negative 4. So my total on this case, the sum of the middle 9 terms, because it's not the first 9, it's the middle 9. There's 9 in the middle there somewhere. Is how many terms I'm adding together? 9 divided by 2 times the first number I'm adding plus the last number I'm adding.
Why would it? Because the first you to add the sum of 40.
Because I 1 to 40. This one does not go from 1. This one does not start at 1. It starts at 6. So I'm not adding the first 14 terms. I'm only adding 9 in the middle. So the sum of those 9 terms in the middle happens to be negative 18. So 0 plus negative 4 is negative 4. Negative 4 divided by 2 is negative 2. Negative 2 times 9 is negative 18. No calculator required. I know, now I'm just showing off. Questions? Yeah, it's what do you need to have to use summation? You need to know how many terms you're adding, what the first one you're adding is, and what the last one you're adding is. And it doesn't have to go from the first one to whatever, it can go anywhere in the middle. Okay? Your turn, do those two. Okay, so in this one here, and the number of terms we're adding in together, that's easy. It's 56 in this case, because we're starting at 1, so it's 1 to 56. The first term, a sub 1, is 4.1 times 1 minus 6, which is negative 1.9. And then a sub 56, our last term, 4.1 times 56 minus 6. And 223.6. So the sum of my first 56 terms in this case, 56, not 65, I'm not dyslexic, 5, 6 over 2 times negative 1.9 plus 223.6. And I get 6,207.6. Is what I got. Next one, I am not adding together the first 79 terms. I'm actually starting at 3. So 79 minus 3 is 76 plus 1. I'm actually adding together 77 terms in the middle. So my n is 77. The third term, which is the one I'm starting with, plug in 3 for 2, I get 2. Plug in 3 for n, I end up getting 1. 7 minus 6 is 1. And then the 79th term, 7 minus 2 times 79 gives me negative 151. 51. So the sum of these 77 terms I'm adding together is 77 over 2 times 1 plus negative 151. So 77 divided by 2 times 150. And I get negative 5775. A couple of new formulas to use. Once again, this chapter is not the most difficult chapter, except for all the formulas you have to keep straight. And you're going to have to use in several different ways. That's what this chapter is about. Okay? I should say that's what makes it difficult.